Suppose you like to enclose a rectangular area with 200-meter fencing material. You need to find the dimensions so that the enclosed area is maximum. So first we draw the picture and consider the variables for the length and width. So we consider this is the rectangular area. Let me say that this length is x and that is y. So this must be y and this must be x. Since we have to use 200 meter of fencing, so around we'll have 2x plus 2y equals 200. So let me write it here as 2x plus 2y equals 200. It is possible to simplify, so I divide each term by 2, so I get x plus y equals 100. Now our objective is to find the area which will be maximum. So we know that the area of a rectangle is x times y. Now from this we can find y in terms of x, which is 100 minus x. So then put it back for y, so you have x and then 100 minus x. So that gives me 100x minus x squared. Since we are looking for maximum and you know calculus, so let us use calculus to take the derivative with respect to x. That gives me 100 minus 2x, and for critical point set equal to 0, solve for x. So then you see that your x will be 100 over 2, which is 50. Now you can check the sign of first derivative. So check the sign of first derivative, meaning is on this line you put 50 in here, take some test points, say in this side 0, and on that side let me put 51. So now we'll check the sign of a prime. So when I replace x by 0, I see that it is positive. When it's 51, so 2x will be more than 100. So then this answer is negative. That means first derivative positive, meaning is graph is going up, and then first derivative negative, meaning is going down. So we understand that at x equals 50, I have maximum area. So then when x is 50, now y will be, you can plug it here, 100 minus 50, so that gives you 50. So the dimension for this problem will be 50 meter by 50 meter. So that will produce the maximum area with the limited resources, 200 meter fencing material, and you are done with this problem. Business application. Suppose you are given a cost function cx, which is 250 plus 20x plus 0.001 x squared. Then the average cost is, the number of units will be x. So if you divide by x, that is average cost. So you get 250 over x plus 20x over x, it gives you 20, plus 0.001 x squared divided by x, will cancel 1x. So that is your average cost. And now the marginal cost will be just the derivative of the cost function. So 250 is a free constant, goes to 0 when you take the derivative. 20x gives you 20, and then keep your 0.001, and the derivative of x squared is 2x. So 2 times 0.001 will be 0.002. So you got the marginal cost. Now we are asking, find the number of units that will minimize average cost. So this is our average cost function. We need to find x so that our cost will be minimum. So let us take the derivative of average cost function. So we can write like this. dc by x, we are taking derivative of that with respect to x. So you understand 250 over x will give you negative 250 over x squared. Free constant 2 goes to 0, plus derivative of that one will be 0.001. Now we need to set this equal to 0 and solve for x. So we can easily see that we are having, if I multiply by x squared, we get negative 250 plus 0.001 x squared equals 0. So then finally you see 0.001 x squared equals 250, and then x squared will be, you divide 250 by 0.001, so 0.001, so that will make it 250000. So now when you take square root on both sides, you get x equals, x is the number of units, so we avoid the negative sign. So 25 will give me 5, and you have 4 zeros, so that will make 2 zeros here. Or you can just use your graphing calculator. You'll see x equals 500. So when you have x equals 500, then our derivative is 0. Now if you go with the test, you will see that x equals 500, I mean the line test. If you have 500 here, and then if you take the test points here, say 100, and you take on this side 600, when you plug on these, you will see that the first, it will be negative here, and then be positive. That means your graph is going down, then it's going up. So at 500, your cost will be minimum. That is the minimum average cost, and we are done.